Welcome to AWS AI demo series. Today we are going to see another project demo of AWS Bedrock Agent. In this video, we explore the cutting edge of Agentic AI orchestrator using AWS Bedrock Agent, Agent Core, and the newly introduced AWS Strands framework. Whether you are building the intelligent workflows, integrating multiple multimodal tools, or deploying scalable automation across the cloud platform, this breakdown will give you the clarity and the confidence to architect your production readiness solutions. Okay, let's go and start exploring the three different services in this demo or this project demo. So where we are going to explain the difference between the Bedrock Agent Core, and the newly introduced Agent Strands framework. Okay, so let's jump onto that and let's get explore. Let's start with first AWS Bedrock Agent. So this architecture is hosted entirely within AWS Cloud and centers around the Bedrock agent, which acts as an orchestrator for user query. Okay, so think its work as a brain and interpret requests with plan actions and calls the right tools to get the answers. On left hand side in the design, you see like user write the below prompts to get the answer, what the conversion rate today to rupees, let's all ec2 instance, list all ec2 instances on the AWS account, what the weather today in Nashville. Okay, so these query are sent directly to the Bedrock agent, which is pass them to foundational model or the LLM hosted on the Bedrock. The foundation model, whether it's Anthropic Cloud or Amazon Titan or other models, interprets the query, understand the intent, and determine the which tool or action is needed. This is where orchestrator magic works, okay, or begins. So next, the agent use the action group to route the request to appropriate tool. Each tool is implemented as a separate AWS Lambda function. For example, tool 1 might be fetch the currency conversion rate via the external API call. Tools 2 could be query EC2 instance using the AWS SDK. Tools 3 might be called the weather services externally. These Lambda functions are modular, secure, and independently deployed, giving you the full control of logic and scalability. As a required development on development side, you will write a Lambda function code for each tool, deploy and manage them independently. Ensure to each tool is the register with the agent's action group. This modular lets you scale, update, or the sweep tools without touching the core agent logic. Okay, and because it's built in AWS, it integrates seamlessly with the IAM service, CloudWatch, Step Function, and many other services. Okay, so that's a full walkthrough or mini walkthrough of the AWS Bedrock agents how it's work with the foundational model and Lambda function tools to create intelligent, modular, and the secure AI workflows. If you are building agentic AI system of cloud native automation, this is the right architecture and this is the right service functionality, which is the Bedrock agent service. Now it's a demo time. We'll be having a actual demo for the Bedrock agent, how it's work. Let's get through the design of this demo. So where we are, our customer agent or like Bedrock agent act as a customer support agent, where it will be fulfill the customer requirement or the questionnaires which is asked, and if the customer is new upcoming customer or like it come from some inquiry, it will be store his first name and email ID in our DynamoDB database if it is missing or not already recorded in register. Okay, so this is the small demo where the two different tools we are going to invoke. First is a AWS DynamoDB, and second is the our consumer facing app, right? So, or like we can use the chatbot, simple chatbot. So let's go and set up this demo and get through it. Okay, thanks. Let's jump on the demo very quickly. Okay, and let's log into the AWS console. So for this demo, we are going to set up the AWS DynamoDB, where all the data will be get stored based on the query result, and then we set up the Lambda to invoke the function or invoke the tools, which is going to insert the data in the DynamoDB and take the query from the agent core, and then we are going to set up the agent, Bedrock agent, and with the agent action group. So where the action will be trigger invoke the Lambda function and DynamoDB. Okay, so let's jump into the DynamoDB first and set up the DynamoDB table first, and then we'll go from there. Okay, so I'm going to use the simple one table, which we're going to create it, create table. So table name we will be defined as interested consumers. Okay, so I just have already typed interested consumer. Make sure you don't have any space or like that. And the partition key will be a simple key customer email. Okay, so it will be one single word customer email. The it will be string only, and just make sure there is no space. So all the things will be remain by default. Okay, and make sure whatever the partition key is case sensitive when you're writing the code in the Lambda or any other function. Okay, so let's create the table. Just refresh and wait for, just make sure the table is ready. While table is getting created, we'll be going to create the Lambda function to execute the Lambda. Okay, so okay, good. So I'll be creating the Lambda function for simple Lambda function, which is the agent tools 01 tool. Okay, we'll be using the Python 3.13 or latest, whatever you want, and then we'll be going to use the existing role which we created. You can create your own Lambda role, but I have created the Bedrock POC role for this. Okay, so which will be use the list permissions for the DynamoDB and Lambda and the Bedrock agent or Bedrock. Okay, and once it is created, then it should be go for the configuration, create the function. So I created the function. Okay, so there is another configuration we need to do for the invoke. So resource based policy we need to add here. Okay, so which will be based on the Bedrock agent only. Okay, so we'll be deploying the code here, and that Lambda code is already I created. So I'll be uploading all these codes on the GitHub. So I have created the simple code where the it will be inject the DynamoDB. So based on the trigger from the AWS Bedrock, it will be match if go back and check the DynamoDB actions and the action group. Based on the action group functions, event will be triggered, and the messages will be captured and cross verify with the DynamoDB. If that consumer is available, it will be response that it's already available. If it is not, then it will be put the items and then register the customer email and customer name in the DynamoDB. So this is the simple function I wrote to insert the DynamoDB table. We'll just copy this and then we'll put it in the Lambda function, which is working, and let's deploy. Will we come back again to the Lambda function once we created the agent to configure a couple of other tools or like configurations. So now our Lambda function is ready. So let's go back to the Bedrock agent. Okay, so we'll be creating the agent. I have another agent already, so we'll be create a new agent here. Okay, that agent will be purely for the demo purpose we are creating. So we'll be give the agent 2. Okay, so I'm not going to do the multi-agent currently, so I'm not going to check mark this. Description is the option. So I'll create an agent. Now agent is created. I'll be going to select the specific model, which will be the existing model or like anthropic model, which is the IQ 3.5. I'm going to use it, and I'm going to use the AWS IAM role service, which is the Bedrock role service role I already created. But you can create the on fly if you have access to IAM service. You can create use new service role, or you can customize your service role. I created customized service role, which will be talk to the AWS Bedrock service, as well as it will talk to the Lambda service and the backend your DynamoDB service. So I'm going to use the Cloud Haiku runtime role. Okay, and after that I'll be come here and deploy, give the instructions to the agent. So how the agent should be behave, right? I add the instruction, so saying that this is the spice food store, and these stores offer widely variety of spices. Okay, so where the different variety of spices available, but there is shortage of one spice, which is red chili or powder, or become available once the stock is available. That's where I give an instruction, and that's where I'll write the invoke function. Okay, so once it is created, we'll be add the agent group. So let's first save this. Okay, I just saved, and now I'm going to add the agent action group. So agent action group will be I'm giving the custom name for this agent action group, which will be the customer interested action group. Okay, so make sure there is no space. Okay, so this action group will be execute the existing Lambda which we were created, the Lambda agent 201. Okay, and it will pick up the latest version of the deployment, and then we will be define the Lambda agent group function, where that function will be have the attributes or like parameters which will be supplied to the Lambda function. Okay, so these are there are two parameters we are going to create here. We'll add the parameter. Okay, the first parameter will be our customer email ID. Okay, and then second parameter will be our customer name. So we'll be writing what is happening like this. Okay, right here. Customer name, make sure the spelling is correct. Customer name, and the description will be customer name, and the type will be string. The requirement is false. Is true here. Okay, and then I'll delete this, and which will be customer email. Just make sure the names are correct. Customer name and the string, and this is also will become a true requirement. This is all required, okay, to insert the data. Okay, so once it is added, we'll create this group. Okay, let's create it. Okay, and then save and exit. So it is not prepared yet, but before that, let's make sure we have all the things which is required. So go back in the edit agent. So agent name we already given, agent 002. We have an existing service we picked up, Haiku 3.5, and then customer interest action group we have created, and then we have enabled it already. So it will be start executing. Then we have created under customer agent group. Once you go in, so we have created the action group. Okay, so under agent action group we have created the execution hook, which is the Lambda service which we created and added the code. Then we have created the action group function, which is one save interested customers. So it will be make sure to save interested customer with these two parameters. Okay, and that parameter to supply the AWS functions. Okay, so we are all good to go. Just make sure the parameter, sometime it will be problem. Okay, so now we all done. The agent details are created. We can save and come out. And now to make sure it's working, we have to prepare this agent. Okay, so agent is getting prepared. Okay, it's prepared. It's very quick. Okay, now just test this agent. So I need to say one command, hello, and let's say if it respond. Okay, so welcome to our Spice food store. How I can help you? We have variety of spices available, including turmeric, cumin, coriander. Okay, so we have got this response now from agent. So now let's go back and allow this function to just copy this function. Okay, so now what we need to do, we need to allow whatever Lambda we have created, we need to allow the resource based policy to access this Lambda by this Bedrock agent. So we'll go back in the configuration, in the permission, we have to go back and add the permission. Here we are using the service. We'll use the other service because it is not the listed service. The service statement we are going to use the Bedrock agent and hook function. Okay, so let me copy already written. So this function will be called out by the Bedrock agent and hook this Lambda service, and the service will be the Bedrock ck.amazon AWS.com. So Bedrock service will be there, and we need to give the agent ARN, just copy this agent ARN here. Okay, and in action we have to mention the lambda and hook. So lambda has to be in hook based on that action. Okay, and just make sure everything is Bedrock, Amazon, AWS.com, Bedrock, agent and hook function, and then other services, and then ARNF, this target agent group, net connect. Okay, so once we have this link available, so now it is available here, and now Bedrock has the access to this agent. So let's check the DynamoDB. Go to the DynamoDB first and check if any record is available. Record is not there, so let's test it first, the function, and just make sure. So before going that, we can going to invoke this function or agent through the two ways. So for testing purpose, you can within the Bedrock you can test this function by giving your prompt, or you can have the Python or like small UI setup which will be used as a UI function. So I have created one small UI code which will be go through this. So app.api. Okay, so before that I have agentic AI which will be already tested here. So we'll be using this. So I'll be using the agent ID and agent alias. So we forgot to create agent alias here. So let's quickly create agent alias. Okay, so we'll create a user version and agent alias name. So whatever we can give the agent alias name, let me check what agent alias name we can give it. So that's where we can use the two different alias names. So demo 01 or something we can give agent 0021 alias, so like that 02 alias we can give. So it will create a new version and it should be good here. So just create an alias. Once the alias is created, we will get the alias ID and we will get the agent ID also. So this is the agent ID we are going to mention in this code base what we created. Okay, and this is my agent ID and this is my alias ID. Okay, so what this simply UI do, it will be create a chatbot for you guys. Okay, this also code I am going to mention in the course stream. I am using this Streamlit UI, simple UI, which will be build UI very quickly for you and host it on your local system. It can be accessed from the local system itself. It will be create a session and reverse session also will be get triggered. Okay, so let's build this. So let's see our demo quickly and check the result. So I'm using the Streamlit UI. Run the app.py which we created to invoke the agent from the Bedrock from our local system, which will be give us the supply the prompt and get the answer directly from the Bedrock and insert the data in the DynamoDB. So let's execute this Streamlit UI. So I got the executed on local system and then just talk to hello world. So it will be give the answer. This is our UI. So, hello, welcome to our spice and food store. How I can help you today? We have various spices available, including turmeric, cumin, coriander, turmeric, cinnamon, and black pepper. So, what do you like to about our spices? Know about spices? So, let's ask the prompt. I want to order the things which is not in the list and how it react. I sorry. Want to order red chili powder. Okay, so it should tell something to take action. Okay, agent responded, I apologize, but red chili powder is currently not available in our store due to logistic reason. However, we can add you in our order notification list so that we can email you as soon as it's become available. Would you like to provide your name and email address to be notified when the red chili powder is back in stock? Yes, I do like. So I'll supply my name is Sumit and my email address is spottr@gmail.com. Okay, so I just enter this data. So let's see what it will notify us. So technically it has to be take my name and register in the database. Yeah, it's done. Thank you, Sumit. I have added your email address in our notification list. We will contact you via email as soon as chili powder become available in our store. Is there anything else I can help you? No. So let's go back and check whether database DynamoDB database got updated or not. Okay, so let's go in the DynamoDB and we are in Dynamo. Just run the refresh. Yeah, so hey, it's now available database. It means inserting. Let's try another way to do it. Let's go back. I can say hello. So it should be give the same prompt, black pepper, and I wanted to order red powder. So it has to be give the same answer. Yeah, so I apologize. The red chili powder is currently not available in store due to logistic reason, blah blah blah, same reason. So then I'll give the different email ID and my name. So let's give my name is S Sunil and my email address is sunil@look.com. Enter. So technically it will be record name. Yeah, thank you, Sunil. I have added your email address in our notification list. Comes from blah blah blah. Okay, so let's go back and then again this also should be available. Yeah, so it is correctly inserted by Bedrock Agent. So this is how the Bedrock Agent works. So we created agent and agent group, and agent group will be calling our Lambda service. We created alias, and the Lambda service will be called out to the DynamoDB and insert the data in DynamoDB using LLM models from the Bedrock, and DynamoDB will have those models. And then on-prem, I created small Python script using the Streamlit, which will be call our Bedrock agent, and take our prompts and insert the database. It will be give the back answers, store our chart history. If you see, and the chart bot which we created Streamlit, it will be storing this chart history also, and it's give you the answer correctly. Okay, so here is the completed demo for the AWS agent, how it's worked from the small use case for the Spice Store customer support chatbot. Okay, this is how it's working. Hope you liked the demo on the Bedrock agent, and you definitely try this demo at your own on your local system and on your AWS account. So make sure you delete all the resources once the testing is completed, so to avoid the charge concurrence charge for you, and the cost for you for Bedrock is very heavy cost service. So now we are moving to our next topic, which is AWS Strands. So let's understand why it is important, how it's work, how it can be set up, and we'll follow the demo with AWS Strands also. So let's jump into the AWS Strands understanding. So AWS Bedrock agent offer powerful orchestration, but they come with the limitations in the flexibility, customization, and hosting control. So this is where AWS Strands framework comes in the picture. Strands give developers full control over the agent logic, development, and tools integration using the model context protocol. So AWS Bedrock agents require significant development effort, especially around the Lambda tools creation and the orchestration setup, whereas the AWS Strands offer the lightweight developer fully alternative with the control over the agent logic and hosting. AWS Strands is a framework designed to simplify the development for AI agent by using a model-driven approach where the agent powered by an LLM like one from the Amazon Bedrock is responsible for its own orchestration and design, making the process works in the loop where the agent receives a prompt, reasons about the task, and then select the invoke the appropriate tools to complete it. So this different from the traditional methods where the developer would have to manually code the complex workflow and state machines. So this design is significantly reduce the development effort needed for the AWS agents. Instead of creating and managing multiple separate lambdas for functions for each action group, Strands allow for a single code base. The framework relies on the LLMs reasoning into plan, chain, through the and call tools, which reduce the need for developer to hard code complex logic. The model first philosophy allows the developer to focus on defining the agent's role and providing the necessary tools with the agent itself, handling the multiple reasoning and tools invocation automatically. The AWS Stands is open source SDK for building a core logic of an AI agent, which is great for the flexibility and customization. However, now we have fully understand how AWS Strands works and how the process flows. So let's quickly jump into the short demo, so which will be explained practically how we can set up the Strands and get utilize that on local system. Okay, coming back to our another demo, which is AWS Strands. So AWS Strands is very simple and basic demo. As I told you, AWS Strands is a single code based framework which will be reduce the less footprint and get to your code base, a small code base, and you can able to call out the different tools, right? So if you look at the screen, I'm in my Visual Studio base code. So I have importing the Strands agent. Okay, this agent model as you importing for the Bedrock model. Okay, and then Strands tools. I'm importing the calculator and current time, use AWS or HTTP request. So to explain this code, it's a very a tiny footprint of the code which will be do the similar service for the as a AWS agent code, but the only difference here is I need not to write the Lambda function or Lambda code for each tools. So if you see here, I'm just simply importing the Strands tools which is ready available, which is calculator, current time, use AWS and HTTPS. So I'm using the this is uh, tools. These tools I'll use to ask the different three questions which I noted here. Okay, then I am calling the Bedrock model. So I'm using the Bedrock service to use the Bedrock foundational model, which is Sonat Cloud Sonat 4. Okay, so which is recently launched by AWS, and then I'm calling those tools to under the agent model. So agent model ID will be called these tools calculator and current time and use case and HTTP request. If this use case I'm going to try with the AWS agent, I need to write the Lambda function for each tool, for the calculator differently, current time differently, AWS service differently, HTTP request differently. We recently saw how we wrote the Lambda service or agent, cloud agent for the to call the insert data in the DynamoDB based on the customer requirement. Okay, so this is the similar kind of demo differently I did. So this is only code, you might be surprised. This is only code which required to run this demo. Okay, so what I'm going to do, I'm going to ask these three questions. Give me a list of S3 buckets in my account. So my account, whatever my account, I am importing the AWS account here. So that account, what are the buckets available, it will be going to ask. So I'm giving the question, I born in 1980, or like I give any random year, I given any random year, and tell me my age in days. So which will be use the calculator tool to calculate the age in days. So the give me S3 bucket in my account, which will be used by AWS tool, use AWS tool. And third question will be give me AWS news. Sorry, give me news on first page of news.google.com website. So I'm asking the website references which will be used by the HTTPS request. Okay, so let's execute this. As I told you in the previous section where I explained how the AWS Strands work, so that will be it will be create the different task for itself. It will be generate the sequence task on its own. It will be calculate or and assume the tools, which tools which should be used for the which question. So this is all the backend MCP server which is Strands built on. It will be used. So let's see how it's work without any other code or not any function. So I have Python script executing AWS demo Strands. I'm running this code. Now let's see the magic, how it's going to be calculate thing first about the branch. Okay, let's see. I will help you to three questions. Let's handle one by one. Tool one use tool one use AWS tool through current time and HTTPS. These three tool use out of these four tools I requested here. Okay, so then it will be give me the all S3 buckets which I have in my account. So there are 36 S3 buckets available in my account. It will give the all list S3 bucket in my account. Okay, So these are the correct, and then it is a second task. It will be calculate my age in the days. So if I give my birth year, born year, it is wrong, but it 1980. But and today being on 20th October, how what is approximately days in days calculation, okay. And top Google News. So if you see here, this is the second answer. First answer, it is given S3 bucket, all 36 with that, those are the right. And it will give the second answer, what is the my age in days. So it's 1600k or like days in the answer. And the top news from Google News. So here is the breaking news from the Google top. Like we can verify by writing in Google News. I'll write news dot google dot com. Okay. If we come here, if we check the news here, so if you top news, if you see thieves stole the crown jewel in 4 minutes from our museum. So if you see the breaking news, so this is the same news appears here, the second news, okay. And this is how it works, okay. So this is all right, what it's give the answer. This is the Strands .py file, okay. And in next demo, this is Strands demo. This is very simple, and if you see here, I'm not writing any code for the Lambda function. I'm not, this is very small tiny code. I'm integrating with the Bedrock agent, Bedrock model, foundational model. I'm calling the model from the Bedrock agent, and the agent will be calling Strands agent will be calling the tools which is I listed here. I'm listed the 4 tools. Out of 4 tools, it used only 3 tools for this demo. It used AWS for the first question. It used the calculator for the second question. It used HTTPS request for the third question. So this is how the Strands work, and this is how we can set up one work on your own and practice it. So to host this, currently I'm hosted on local. That's what you're not able to see. But if I want to host this as a product or production app, I need to go through the lot of integration services, and that's where third-party services like the authentication, authorization, and then your load balancing, observability, logs, and everything. So that's where the AWS agent core comes in the picture. Okay, so we are going to use the same demo Python file, which is the Strands demo. This is code base, and we are trying to host this in the next demo on the AWS agent core. The AWS Strands is open source SDK for building a core logic of an AI agent, which is great for the flexibility and customization. However, as open source framework, Strands require the developer to manually integrate and configure the separate services for the production grade features. For example, to ensure the security and manage users' identities, you would need to use the service like AWS IAM or Cognito. Similarly, for the observability and the monitoring, you would have to manually set up the CloudWatch and distribute the tracing with the AWS X-Ray. So this is where AWS Agent Core comes in. Okay, so it's a fully managed platform that provides the complex production ready environment. Agent Core fulfills the needs to that Strands leaves to the developer by the building in these critical features. It natively provides the secure, isolated runtime environment and the handles identities and access management for you. So additionally, it offers built-in observability with the logs, metrics, and the trace, so developers can easily monitor and debug their agents without needing to the manually configure and manage the services by using the agent core. And developer can take an agent built and Strands and deploy with the enterprise grade security, scalability, and monitoring feature in the one managed solution. If you have been exploring agentic AI frameworks like Strands and wondering how to deploy them securely at scale, so Agent Core is your answer. Let's break down how it works, what it offers, and how you can use to build production grade agents. So Agent Core is the managed runtime service within the Amazon Bedrock that powers agentic workflows. It handles the heavy lifting like memory management, tool invocations, identity integrations, and observability. So you can focus on building intelligent agents. Okay, let's talk through the architecture. When the user sends a query to your agent, agent code does the following. Session initialization. It creates a secure isolated runtime session for the agent. Then memory management. The agent core provides the API to short-term and long-term memory. You can store users' preferences, past integrations, or the present knowledge. Then tools invocation, it securely calls the tools whether you are Lambda function, API, or browser code integration based on the agent's reasons. Okay, model invocation, it routes the query to the fundamental models like cloud or Titan hosted on the Bedrock. So response compatible returns the structure response which agent core format and sends back to user. All of this happens within the secure observable environment within the support for the CloudWatch, Open and IAM roles. It compatible with the frameworks like Strands agents, and LangGraphs and Llama Index, and the support both Bedrock hosted and external foundational model. You can deploy agent and to agent core using the agent core start toolkit. It supports Python 3.10 plus and integration with the AWS CLI and SDKs. You will define your agent logic, configure, model access, and deploy using the single command. Agent core handles runtime, scale, session, presentation, and then tools executions. If you look at the diagram presenting on the screen, which will be talks about how AWS Strands can be deployed on agent core. So the process flow, if you see on the screen, okay, so I'm using the same AWS Strands workflow which is in the previous Strands for workflow. Only difference here is we are hosting this Strands on the Bedrock agent core. So here is the workflow. So we have the strands.py Python file where we have the strands code defined in that, and we will be having the requirement.txt file which will be put all the models or the Python models required to be strands to be implemented or pip commands, and then we will be run the agent core configure command on the AWS CLI. Through that, it will be generate the Docker file. That Docker file will be used for the agent core launch, which will be stored all the files, Docker files, or strands py files, or the requirement.txt file in the S3 bucket. Therefore, I'm using the code build and deploy service within the AWS itself. We can use any other CI/CD pipeline service to deploy this. So the code build and code deploy will generate the container image or Docker image, and it will be deployed to the AWS ECR service as a Docker image. So that Docker image will be pulled out or deployed or integrated with the Bedrock core agent, and Bedrock core agent will start spinning up all the services automatically through that Docker image file. So we are mentioning all the strands .py files or requirement.py files, everything, and the Docker image itself which will give based on the Docker files which we created. So that will be deployed through the Bedrock agent core. Agent core will be deployed all identity integration, observability integration, and the log integration. Then your all the store integrations, and the creates it all agent required tools or MCP server or Lambda, whatever you explain to execution in the invoke the third party tools or the model LLM which will be defined in the Strands file. After that, it will be create the endpoints which will be the consumer can be utilized, and through that the consumer or the end user can be deliver these prompts and get the answer. So all this happen within the Bedrock agent core or Bedrock services. So it will be spin up all the integration automatically. You not to do anything. Only you need to do the build your strands.py file and the requirement.py file, which will be going to see in your our demo. So that for today we are going to stop here as a first video. It will be second series of this video coming next very soon, which will be we are demonstrating AWS agent core service. Okay, thanks for your time watching this, and keep learning, keep updating yourself to stay in the AI world. Thanks.